In this video, we will be giving shape and size to a particle. So far, we have considered particle to be a point having zero dimension. In this video, we will be considering particle to be a line having one dimension to it. And in the subsequent lectures, we will be giving 2 and 3 dimension to a particle. So in order to actually understand how to code for this type of problem, considering point to be a line, we have to consider the equation of line in continuous form as y is equal to mx plus c. You actually, as it is known that if you had a code for it, you don't go for continuous form. You always have to go for discretized form, in which line is to be considered to be made of number of points, and the coordinates of each and every point is considered in it and sampled like this, in sampled into n numbers. Okay, this is the way you will be coding for a line in any language. Machines always is applicable if you consider it in discretized form. Okay, so in order to code this type problem, we have considered x and y coordinates having number of particles in it: x1, x2, y1, y2. So far we considered each column represent different particles. Now from this video onwards, we will consider each row to be one particle giving its discretized form. Having these both these coordinates belongs to same particle. So this is a line, and the line will be represented by only 2 points for a start. Yep, and they will be considered as one particle. And the second function, we will develop a function center of mass to calculate the center of mass of this particle, which may be needed later on when we are going to talk about the force in particle motion, where it will be needed, center of mass will be needed for the stability of the particle. Center of mass is given by x-axis x1 is equal in x-axis x center of mass will be x1 plus x2 divided by 2. Yc would be equivalent to y1 plus y2 divided by 2. For n particles, xc would be equivalent to x1 plus x2 plus up to xn divided by n, and x and yc would be y1 plus y2 yn up to yn divided by n. If particles, these points would have mass, different mass to it, mass distribution would be different, then you can go for generalized center of mass for these type of problem as m1 x1 plus m2 x2 plus up to mn xn divided by total mass m. Similarly, m1 y1 plus m2 y2 up to mn yn divided by total mass m to calculate the center of mass of the body. Okay, let's go for the shape and size of the particle. I think I need the same thing. Let's take it first. Shape, size. Let's copy the same thing. I would want it to fall down. And I'm going to create a function. Name it structure state. No, wait a second, that is wrong. I'll name it here. Yep, structure shape. Save it as that. Cross these two things. Okay, shape and size. Let's code for it. I want first of all particle to fall down. First, I'm going to create it. Keep it at top. So particle, number of particles 9. Number of particle corresponding to number of points corresponding to same particle. Okay, let's make it like this. That keep it at top and bound is okay. We'll just see what we need as we're gonna code. Okay, two should be same. Let's see where the particle. Yep, here are the particles, two particles. These points should corresponding to same particle. Okay. First, we're going to the center of mass. So I have to create a function center of mass function to return the coordinates. COR is equal to center mass, and it will have the given the same coordinate x, y, and z. Okay, and the thing is I is equal to size of 0 slash 1 along second dimension along the column plus 1, and COR is equal to, I don't need to just do that thing, I don't think that thing, CO, whatever the x-axis, like first there will be x-axis, two coordinates 1 and 2, I will add up third one, which I will give center of mass. So I have to do the mean. It just I will do mean. So mean is equal to man is not mean of CO. Yep, that would be it. And I'm gonna add that part at last. I think this will work. Now to see if it's I just need to add another coordinate or another coordinate to x. So what I mean, I will keep x as center of mass and I will give it the x coordinates. Let's say what is the output. 10. Yep, center of mass is 10. That is correct. Exactly what I wanted. So I have updated the center of mass. For now, this will be like constant, having same. I report having same mass, same for y, and same thing for z. Let's plot this up. Yep. Now I have 3 points. Middle one is the center of mass. Nice. Every rows correspond to the same particle. So this is it. Direction cosine. So I need it to fall downwards. Nice. And how am I gonna make it to fall downwards? Structure state. This won't be changing. Xi won't be changing. Y I won't be changing. And down it will go with minus. So velocity should be -5. I do better. Maybe in next lecture I will give different velocity to different coordinates. But start. This is it. This is gonna be yeah, the T and Z. Okay, what angle it will be given x, y, and z axis. Let's not talk about direction cosines this time. No direction cosines, we won't be talking about direction cosines. Just let it fall down. Okay, let's play this out. Error in the shape size. Wait a second. ZI. VI. Okay, now it's good. Every particle should have same velocity. That's what it was actually happening. So it will be same. I don't have to do. Yeah, I just using wrong. Fine. I had to use this state function. I'm using wrong state function. Now it's good. Okay, this thing. Just don't talk about x, y, and z this time. Let it fell down. Yep, it's going beyond. I didn't limit its Zdi size. I just did limit its. If Zdi is greater than B is set 2 or the boundary condition 1 is less than it should be. Then it should be plus actually. Then it's wrong. Understood. For you can't just go for both things. Yep, that is right. So I have this is wrong. If this is this, okay, I'll go for if. Here, if it is less than, let's go for plus. You can go for same z and y axis. We can do it next when we need it. This time we don't need it. Okay, okay, nice. Everything is working out. That's what we wanted it